In this lesson, we're going to begin our series of lessons with linear equations where you have multiple lines, and more specifically, when you have two lines. We're going to begin by looking at parallel and perpendicular lines. Remember, parallel lines are lines that never intersect. When you have parallel lines and you're looking at them algebraically, so you're looking at their equations, you will notice they have the same slope. So when you look at the two lines to the left, you can tell visually that these are parallel. You can see that they're going to stay the same distance apart and never cross. But you want to be able to look at two equations and be able to tell the same thing. For example, if I had the equation y equals 2x plus 1 and the equation y equals 2x minus 1. Simply by looking at these equations, I know that they are parallel because they have the same slope. When you have perpendicular lines, remember, these are lines that intersect at a 90-degree angle. Algebraically, so again, looking at their equations, the slope for these lines, they have negative or opposite reciprocal slopes. So again, to the left, you can see visually that these two lines are perpendicular because they cross at a 90-degree angle. If I were to look at the equation y equals 2x plus 1 and y equals negative 1/2 x plus 5, simply by looking at these equations and comparing the slope, so 2 and negative 1/2, 2 and negative 1/2 are opposite reciprocals. So I know that these lines, just by looking at the equations, are perpendicular. So let's focus for just a second on that opposite reciprocal. Let's review that a little bit. So remember, opposite reciprocal is a fraction that is flipped. And that means also the sign is switched. So we flip the fraction and then we switch the sign. So if it's positive, we change it to a negative, and if it's negative, we change it to a positive. So to practice that, let's look at a couple of examples. 3/4, its opposite reciprocal would be negative 4/3, because again, we're flipping the fraction and we change the sign to the opposite. Number 2, when you have a whole number, that's like saying 2 over 1. So if we were to flip that, that would be 1/2, and its opposite would be a negative 1/2. So its opposite reciprocal is negative 1/2. Number 3, again, if we flip 7/8, it's 8/7, and then its opposite is that it's going to be positive because in the original number it's negative. So the opposite reciprocal of negative 7/8 is 8/7. On number 4, we'll do the same thing that we did for number 2. We put it over 1. The opposite reciprocal is negative 1 because instead of positive, it's negative, and when we flip it, we still get 1 because 1 over 1 is 1. For 0, we're going to do the same thing. Put it over 1. When we flip that, that's 1 over 0. And remember, we don't want 0 in our denominator, so that means it's going to be undefined. Because remember, we're talking about the slope. We're comparing the slopes of two lines. let's take a look at some examples of just determining if the lines are parallel, perpendicular, or neither. So when I take a look at number 1, I'm given the line AB goes through these 2 points, and line CD goes through these 2 points. And I want to compare their slopes to determine if these 2 lines are parallel, perpendicular, or neither. And I'm doing this to compare it algebraically what these 2 lines are doing. So what I need to do is find the slope of each line. So I'm going to name this first point, or this first set of points, that first line 1 and then 2. So to find the slope of my first one, using my first 2 points here, again finding that slope, y2 minus y1 over x2 minus x1. And you can label your points if that's helpful. x1, y1, x2, y2. So when I substitute these in, I get 6 minus 3 over 2 minus negative 2. 6 minus 3 is 3. 2 minus negative 2 is 4. So the slope of my first line is 3/4. My second line, because we're comparing these 2 slopes, we're going to do the same thing. But we're going to use my 2 points for my second line. And again, if it's helpful, label your points. x1, y1, x2, y2. And then we're going to plug them into that same formula. y2 minus y1 over x2 minus x1. So when I plug those points in, I get 3 minus 0 over 3 minus negative 1. 3 minus 0 is 3, and 3 minus negative 1 is 4. Now that I know the slope of my 2 lines, I can compare these 2 slopes, 3/4 and 3/4. Based on the information above, when my slopes are the same, my slopes are equal, I know I have parallel lines. Let's take a look at another example. Again, I'm given 2 lines, line AB and CD, and those 2 lines go with their respective points. And I'm going to label the first one as line 1 and the second one as line 2. And I'm just determining if these lines are parallel, perpendicular, or neither by comparing their slopes. So I'm going to find the slope of each line. And to find the slope given 2 points, y2 minus y1 over x2 minus x1. And again, if it's helpful, label those points, x1, y1, x2, y2. So when I plug those in, that's 4 minus 2 over 5 minus 0. 4 minus 2 is 2, and 5 minus 0 is 5. So the slope of my first line is 2/5. My second line, I'm going to do the same thing. I'm going to calculate the slope using my slope formula, y2 minus y1 over x2 minus x1. I'm going to label my points, x1, y1, x2, y2, and I'm going to plug them into my formula. So it'll be 3 minus 8 over 3 minus 1. 3 minus 8 is negative 5, and 3 minus 1 is 2. Now that I have my 2 slopes, 2/5 and negative 5/2, comparing these two, I can see that they're opposites. One's positive and one is negative, and they're reciprocals because they're flipped. 2/5 flipped is 5/2. Because they are opposite reciprocals, I know my 2 lines are perpendicular. Let's take a look at one more example. Number 3. again, I'm given two lines, line AB and CD, and I'm given 2 points that go through those lines. I'm going to find the slope of each line and compare it to see if I'm given two lines that are parallel, perpendicular, or neither. My first line, using my slope formula, y2 minus y1 over x2 minus x1, I'm going to plug in my point 6 minus 8 over 2 minus negative 1. 6 minus 8 is negative 2, and 2 minus negative 1 is a positive 3. So the slope of my first line is negative 2/3. My second line, I'm going to use that same slope formula, y2 minus y1 over x2 minus x1. And I'm going to use the points for line CD to calculate that slope. 3 minus 2 over 3 minus negative 1. 3 minus 2 is 1. 3 minus negative 1 is 4. So the slope of my first line is negative 2/3, and the slope of my second line is 1/4. These two slopes are opposites. One's positive and one is negative, but they are not reciprocals of each other. If I flip 2/3, I don't get 1/4. So they're not the same, and these slopes are not opposite reciprocals. So my two lines are neither parallel or perpendicular. Go ahead and highlight number 4, 5, and 6 on this page, and 7 and 8 on the next page. And then let's take a look at determining if my lines are parallel, perpendicular, or neither given an equation. When you're given an equation, we still want to determine if they're parallel, perpendicular, or neither algebraically. So we want to be able to look at the equations to determine it. We're still comparing our slopes. So when we look at the two equations for number 9, and we look at our slopes, the first equation has a slope of 7, and the second equation has a slope of 7. Our slopes are the same. Because the slopes are equal, I know I have parallel lines. Number 10, comparing my slopes, 4/5 and negative 5/4. They're opposites, one's positive and one is negative, and they're reciprocals. I can flip 4/5 and get 5/4. So comparing these two slopes, I know my two lines are perpendicular. Let's look at one more example. Number 11, comparing my slopes, negative 1/3 and positive 1/3. They're opposites, one is positive and one is negative, but they're not reciprocals. So they are neither parallel or perpendicular. They must be opposite and reciprocals to be perpendicular, and they must be exactly the same to be parallel. Go ahead and highlight 12 through 16. And you can mark out the summary at the bottom of the page.